Good day everybody, we got an interesting question. Not only interesting, but it is also a challenging question. We are expected to integrate integral dx over 1 positive x to the power of 6. Now, there is an expansion related with 1 positive x to the power of 6, which is written as follows. 1 positive x squared multiplied with 1 negative x squared positive x to the power of 4. So, if you were to multiply this, you would get 1 positive x to the power of 6. So let me show you that 1 multiplied with the entire thing would give me 1 negative x squared positive x to the power of 4, followed by x squared multiplied with 1 and with 4 and with 6. So negative, positive, positive, negative goes away, giving you 1 positive x to the power of 6. So that is the equivalent expansion for 1 positive x to the power of 6. So this is rewritten as dx divided by 1 positive x squared times 1 negative x squared positive x to the power of 4. Now what I wish to do is I want to get rid of this. So to get rid of this, what I would do is I would just add a 1 positive x squared there, but I would have to remove this x squared out. So I'm going to place this like this. So add x squared negative x squared and multiply with dx divided by 1 positive x squared times 1 negative x squared positive x to the power of 4. Now this is rewritten as integral 1 positive x squared times dx over 1 positive x squared times 1 negative x squared positive x to the power of 4 negative integral x squared over the denominator. The denominator is nothing but 1 positive x to the power of 6. So I will just write that as 1 positive x to the power of 6 times dx. Now 1 positive x squared gets cancelled, giving me integral dx over 1 negative x squared positive x to the power of 4 negative integral x squared over. Now this can be rewritten as 1 positive x to the power of 3 raised to the power of 2, which you can clearly visualize can easily be integrated. Now for this, what I wish to do is I would want to actually split this. So my splitting is going to be as follows. So what I will do, I will add x squared positive 1 and I'm going to take out that x squared along with negative 1. So clearly x squared can be cancelled, but negative will become positive 1. So that means 1 and 1 is added. So I'm getting a 2 there. Now you might be wondering why exactly I did like this. You will just see it within a minute. Now because of the 2 being present in the numerator, I counter it with the 2 in the denominator, and this is going to be 1 negative x squared positive x to the power of 4 negative integral x squared divided by 1 positive x to the power of 3 raised to the power of 2 times dx. Okay, I have got this. Now what I wish to do is I would want to split these two quantities out. So 1 over 2 is there, so let me push it into the parenthesis, outside the parenthesis. So this is going to be, say, let me write this as 1 positive x squared, the first term, divided by the denominator 1 negative x squared positive x to the power of 4 with the dx, and then negative integral x squared negative 1 divided by 1 negative x squared positive x to the power of 4 times the dx negative integral x squared divided by 1 positive x to the power of 3 raised to the power of 2 times the dx. Now if I were to take x squared outside, I would get 1 over x squared positive 1 times dx. Okay, now if I were to take x squared out, I need to foremost concentrate like with these two terms first. So if you were to take x squared out, however, I'm going to get 1 over x squared here, and then a negative 1 and a positive x squared. So I need to be careful how exactly I am aligning the terms. So that is of critical importance. Okay, so you got the integral there and the parenthesis with 1 over 2. Okay, so and so for that. Now in this case, let me take the x squared out. I get 1 negative 1 over x squared multiplied with dx. You got the integral sign divided by, I got x squared out, so that would give me a 1 over x squared negative 1 positive x to the power of 3 negative integral x squared over 1 positive x to the power of 3 raised to the power of 2 times dx. So this is what I've got. Now let me go to the new side. Before I go to the new side, I cancel this and this, cancel this and this. Okay. Now this is what I've got. Now I have to suitably rewrite the quantity in the denominator as a perfect square. Now that is going to be an important part in this, because let me first consider this quantity. What I've got x squared negative 1 positive 1 over x squared. So I need to generate this in the numerator. Okay, so if I differentiate an x, I get a 1, and if I were to differentiate 1 over x, I get a negative 1 over x squared. So this is going to be x negative 1 over x, because if I differentiate negative 1 over x, I would get a positive 1 over x squared. Okay, so I raise it to the power of 2. Now the question is, when I expand this, will I get the left hand side? That is imperative, right? So I expand this and see, I get x squared negative 1 positive, this is going to be 2 times x into 1 over x. So I'm getting a negative 2 there with a positive 1 over x squared. So I get the first term, I get the last term, but I'm getting an additional negative 1. I need to remove that negative 1. So how do I remove the negative 1? By adding a 1. So I need to add a 1 here. If I were to add a 1 here, this negative 2 with this 1 would give me negative 1. So fair enough. So that issue is solved. Coming back to this quantity, the second one, I have x squared negative 1 positive 1 over x squared. Right? Now I need to generate this one. I need to generate 1 negative 1 over x squared. Now if I differentiate x, I get 1, but if I differentiate 1 over x, I can get negative 1 over x squared. So that's fair enough. So I'm going to place the x here, and I will place positive 1 over x. So let's check that out. If I were to differentiate this, I get 1. I differentiate this, I get the numerator. Okay, that's fair enough. But if I were to expand this, what do I get? I get x squared positive 2 and positive 1 over x squared. I get the first term, I get the last term, but I am not getting the second term, right? Negative 1 should be the second term. So to get the negative 1, what I'm going to do is I need to subtract a 3, right? If I subtract a 3, negative 3 added with 2 would give me negative 1. So fair enough. So we have actually solved the entire component. So let me utilize this and rewrite the quantity. So this is equal to 1 over 2 integral, we would write this as 1 positive 1 over x whole square times dx divided by x negative 1 over x whole squared positive 1 for the first term. For the next term, it's going to be integral 1 negative 1 over x squared times dx divided by x positive 1 over x whole squared negative 3, and the last term that we have is negative integral x squared 1 positive x to the power of 3 raised to the power of 2 times dx. Okay, so this is what we've got. Now to handle the first one, okay, this 1 over 2 is actually moving, right? It is actually till here. 1 over 2 is till here. That's important, right? It's up to here. Okay, so let me place that parenthesis. Now if you consider this, okay, I'm going to consider integral 1 positive 1 over x squared multiplied with dx divided by x negative 1 over x whole squared positive 1. Let me take x negative 1 over x to be equal to sum u. I get a 1. I get a positive 1 over x squared times dx is equal to du. You substitute that. This is equal to integral du divided by this quantity is u squared positive 1. What is this? This is tan inverse of u, which is nothing but tan inverse of x negative 1 over x. So that's solved. Second quantity, integral 1 negative 1 over x squared times dx divided by x positive 1 over x the whole squared negative 3. I take x positive 1 over x is equal to sum p. I get a 1 negative 1 over x squared into dx is equal to dp. You substitute that, you get dp divided by p squared negative 3. I can rewrite this as dp over p squared negative root of 3 raised to the power of 2. Now what is this? Let me write the formula. This is nothing but integral dx over x squared negative a squared. I just did this question in the previous lesson. Please check it out. It's nothing but 1 over 2a ln modulus of x negative a divided by x positive a plus arbitrary constant c. So use that formula. So this is going to be 1 over 2a, my a is root of 3, and ln modulus p negative root 3 divided by p positive root of 3. I don't want to place the positive c as of now. We can place it towards the end. But what is my p? My p is x positive 1 over x. So I need to substitute that. So where would I do that? So let me just use a space here. So this is equal to 1 over 2 times the root of 3 ln modulus x positive 1 over x, x positive 1 over x negative root of 3 divided by x positive 1 over x positive root of 3. Okay, now I need to club this and this, and I got one more quantity I have got. So I need to evaluate that quantity. Let me just go to the next side of the paper. Okay, I'm looking for. Okay, let me use this part of the sheet. So this is equal to. Now consider. What I need to do, I need to consider this quantity, the left out quantity, x squared over 1 positive x to the power of 3 the whole square times dx. Now I'm going to take x to the power of 3 is equal to sum m. This is 3 times x squared dx is equal to dm. So x squared dx is equal to dm over 3. Substitute that. This is equal to 1 over 3 times integral dm divided by 1 positive m squared. Now what is this? This is again tan inverse of m, which is equal to 1 over 3 tan inverse of x to the power of 3. Okay, so take all of this. So I'm going to take this as some alpha. So alpha is rewritten as, therefore alpha becomes 1 over 2 times. The first quantity is, what's the first quantity? This is the first quantity. Right, this one is tan inverse of x negative 1 over x. So substitute that, tan inverse of x negative 1 over x. The second quantity is this. Substitute that with a negative sign in between, negative 1 over 2 times the root of 3 ln modulus x positive 1 over x negative root 3 divided by x positive 1 over x positive root of 3. That's for the first two terms, these two terms. Well, you are the last term, negative 1 over 3 tan inverse of x cubed. Okay, now if you want, you can simplify this. You can actually bring this 1 over 2 inside and you can simplify this. So I can rewrite this as 1 over 2 tan inverse of, if you want, you can rewrite this as x squared negative 1 over x, and then negative 1 over 2 into 1 over 2 is going to be 4 times the root of 3. This can be rewritten as ln modulus of x squared positive 1 divided by x, and if you were to take the LCM as x, right, this is going to be root of 3 times x divided by x, and say that x can be cancelled, so it's going to be x squared positive 1 positive root of 3 times x. Okay, and then negative 1 over 3 times tan inverse of x cubed. So this is a beautiful solution. Don't forget to place the arbitrary constant c, and that is the end of this particular problem. Thank you everybody. Please make sure to like, share, subscribe and leave your comments. Until we meet again.